Hello everyone, I am Snigdha Kakar and this is my channel Accelerate AI Careers. Today I have brought you a very interesting LeetCode problem, LeetCode 264, ugly number 2. This question is very important for FAANG companies that they have asked it in their last 1 to 2 months of interviews. And it is one of the favorite questions for several other companies such as Microsoft, Salesforce, etc. So let's look at what this question says. So what is an ugly number? An ugly number is a positive integer which has prime factors either 2, 3 or 5, and those prime factors are limited to these only. You are given an integer n and you have to point or return the nth ugly number. You have to basically list out all the ugly numbers till the index n and then return the nth ugly number. Let me explain it with an example and the intuition behind this question, and then I'll go through all the approaches you can take to solve this question. Here in example 1, you have been given n equal to 10 and your output is 12. Why? Because your list of first 10 ugly numbers is this 1 and then 1 multiplied by 2, 1 multiplied by 3 and 1 multiplied by 5. So 1, 2, 3, 5. Then 2 multiplied by 2 which is 4, 2 multiplied by 3 which is 6 and 2 multiplied by 5 which is 10. And then 3 multiplied by 2 which is 6, 3 multiplied by 3 which is 9 and then 3 multiplied by 5, 15, but it is like after 10th index so it's not been here. Then 4 multiplied by 2 which is 8, 4 multiplied by 3 which is 12 and 4 multiplied by 5 which is 20, which is out of bounds since we need only n equal to 10. And all these numbers when we sort them, then n equal to 10 comes out to 12, and that's your output here. Now in example 2, n equal to 1, so your first number will be 1 because even though 1 doesn't have prime factors as 2, 3 or 5, that's our base case. So 1 has no prime factors, therefore all of its prime factors are limited to 2, 3 and 5 only as given in the explanation here. And I think the examiner's intuition behind giving this as a part of example is to let you know that your base case is n equal to 1, which is 1, right? And there are some constraints given on n which we don't really care about right now. So what will be your brute force approach to solve this question? Your brute force approach will be first listing out 1 and then multiplied by 2, multiplied by 3 and multiplied by 5. Then take the minimum out of these. Take 2, multiplied it by 2, multiplied it by 3 and multiplied by 5, which is 10. And then take 3, multiplied it by 2, which is 6, but you already have 6 earlier, so you have to handle the duplicates. Then 3 multiplied by 3, which would be 9, and then 3 multiplied by 5, which would be 15. And then you take 5 multiplied by 2, which is 10, which has happened earlier, and 5 multiplied by 3, which is 15, and 5 multiplied 15 has also occurred earlier, and then 5 multiplied by 5, 25. And then you will do 4 multiplied by 2, which is 8, and then 4 multiplied by 3, which is 12, and then 4 multiplied by 5, which is 20, and so on. You will keep on doing this, and then you will sort all the values you have got, and then you will return the value which is at 10th index, right? N equal to 10. This is the brute force approach, but this is a lot more complicated because you have to handle the duplicates. You have to sort them all, and sorting complexity is O of n log n. And then you have to find all these using a for loop. Can we have a better approach to solve this question? So if you look at these values, it seems like a graph or a priority queue question, because when you multiply 1 by 2, 3 and 5, you get these. Then you multiply 2 by 4, 6 and 10. So you take 1 and 2 out, and then you take 3 out, and then you have to find 4, 6, 5 and 10. You have to find the minimum out of them. You take the minimum, which would be 4, and then you multiply 4 by 2, 4 by 3 and 4 by 5, where you'll get 8, 12 and 20. Again, with the remaining numbers in the heap, you will sort them out, find the minimum and pop it out. And that's how you will have a sorted array and you will return n equal to 10. So it's kind of minHeap or priority queue question. If it is not clear yet, let me solve it using coding and you will understand it better. This is not the most optimal approach, but it's a good approach. So you should know this solution. So let's code it first. We'll initialize our minHeap with our base case, which is 1. Now I will initialize a set to keep a track of all the duplicates. Whatever values have occurred or have been put in the heap, I will put them here in visit set. And then I will have also a factors array where I will keep my 3 factors, which can only be the factors 2, 3 and 5. And now I will have a for loop for I in range. And what would be the range limited to? It would be limited to n because I have to return the nth value. So this, and then I will get nums. My nums would be my any heap q, heap pop, and I will push min heap. So I will get the nth value from there. How will I know this that this is the nth value? So I will check if my I index is equal to n minus 1. If it is, then I will return my nums because that is the value desired for returning. If it is not the n minus 1th index, I have to multiply it by the factors that are 2, 3, and 5. So whatever value I have popped up, that is the minimum at that point. And I have to multiply that value with 2, 3, and 5 to add more factors. So for f in factors, if this nums multiplied by f is not in. So if it is there in the set, in the visit set, then I don't need to add it because it's already there, right? So I multiply, say, suppose my 2 with 2, 3, and 5, and I'll check if 4 is already there in the set. If it is already there in the set, I don't need to add it again. If it is not there in the set, I will add visit.add nums multiplied by f. So I have added it to the set, and I also have to add it to the heap. So heap q, heap push, and I will push it to min heap. And what do I need to push? Nums multiplied by f. So this is my entire code. You don't need to have a return in the end here. Why? Because you're handling the return here. As soon as your index I gets equal to n minus 1, it will return nums. So let me explain you the code again. Your min heap is initialized by your base case, which is 1, as shown in example 2. Then you initialize your visit set, where you will track of all the visited numbers, and then you will initialize your array for factors. Now for I in range n, because you have to return the nth value, so you are running the for loop till n, you always pop the min from the min heap, and that's how you pop it. And you check if your index is equal to n minus 1. If it is, you return that number. If it is not equal to that, then you have to multiply it with the factors 2, 3, 5. That's what I'm doing in this loop. And I'm checking if it is there in the visit set or not. If it is not in the visit set yet, so I add it to the visit set and I push it to the heap. So let's run it. It's accepted. Let's submit. So as you can see, our solution is doing really great here. Now, what would be the time complexity for this question? So the time complexity for this solution would be O of n log n. Why? Because you are running a for loop for the range n here. And then you are running till the depth of log n. So O of n log n. And the space complexity would be O of n because you're using a hash set to track duplicates. So that would be your space complexity. Is there a better approach to solve this question? So let's look at it. So there is a better approach actually. In example 1, we decided to go with min heap because we didn't want to sort them out and take a time complexity of O of n log n. And that's why we thought we'll go with min heap, and every time we come across a new number, we will add its vectors and then we will pop the minimum one out of the heap. That was the basic logic behind using a priority queue or a min heap, right? Now, if say suppose we do not need a min heap and we do not need sorting, instead we just need to find a minimum value every time we add a new factor. So say suppose we have a base case as 1. Now we multiply 1 by 2, we multiply 1 by 3, and we multiply 1 by 5. And we have 3 pointers instead of 1 pointer. So we will have I2 pointer, I3 pointer, and I5 pointer. And we just keep on incrementing these pointers based on which value we pick up next. So basically, out of 2, 3, and 5, which one is minimum? The minimum is 2. So I will increment my I2. So initially, all of these 3 pointers would be at 0th index. Because 0th index will be only one element, which is 1. So my I2, I3, I5 all will be at 0th index, which will be here. Now, out of 1 multiplied by 2, 1 multiplied by 3, and 1 multiplied by 5, my minimum value is 2. So that needs to be added to the array next, right? So I will remove I2 from here and increment I2 to here, and I will add 2 to array. So now this 2 will get added to the array. I3, I, and I5 will still be at 0th index. Now I will have I2 multiplied by 2. Now I will take a minimum of 3. So I2 is at 2. My I3 will be at 0 again. I5 will be at 0 again. Now I will take minimum of 3, 5, and 4. So the minimum would be 3. So in this scenario, my I3 will move from 0th index to here to 3. and my 3 will get multiplied by 3, 9. And then we will check for minimum of I2, I3 and I5. My I3 is at 3, I2 is at 2 and I5 is at 0. So we will check minimum of 5, 4, and so out of these minimum would be at 5. So my I5 will get removed from here and will get added here. Basically, instead of using a min heap to get the minimum value popped out, every time I move my indices, I will check which index to move, and that's how I will keep on moving. And when I have moved all the indices and I have added n minus 1 values to the array, I will return the n minus 1th index one. That's as simple as that. Let me explain you through the code and you will understand it better. And then I'll go through the time complexity of it. So let me initialize my nums array by default value, which is 1. So my index 0 is already sorted. So I will set I2, I3 and I5 all at 0 index initially because I have only one element in the array. Now I will run the for loop for I in range 1 to n because I already have index 0 already positioned. So I will start from 1 to n and my next num would be the minimum of nums I2 multiplied by 2, nums I3 multiplied by 3 and nums I5 multiplied by 5. So that's how I'm going to do. So since I2, I3 and I5 both have value as 1 right now. So 1 multiplied by 2, 1 multiplied by 3 and 1 multiplied by 5. And then we'll pick up 2 because 2 is the minimum, right? And then we will have 2 as the I2 new pointer, right? I2 will be pointing to 2. So 2 multiplied by 2 would be 4. I3 will still be at 1. So 1 multiplied by 3 and 1 multiplied by 5. And so on your loop will go on. And now once you have your next num, you will append it to the nums array. So nums dot append next num. Now you will, since you need to increment the pointer, but you don't know which pointer to increment, you don't know what choice was made earlier. So you will check through if loop, if next num is equal to nums I2 multiplied by 2. If that is the case, then increment I2 plus equal to 1. But it could be the case that two values like nums I2 multiplied by 2 is 6 and nums I3 multiplied by 3 is also 6. In such a scenario, you have to increment both the pointers. So you will handle such a case by not using else if here, instead using an if statement here. And that ways you will increment both the pointers nums I3 multiplied by 3 and you will check I3, increment I3, and similarly you will do for I5. So whatever value was chosen as the minimum, that pointer will get incremented next. I5 incremented by. So that's the entire code and this loop will run till the nth index and you will return n minus 1 because that is your final value. Let's run this code, accept it, let's submit. As you can see, our solution is doing really well here. The time complexity for this solution would be O of n and the space complexity would also be linear O of n. So this solution is more time effective if you see, but this approach is not very intuitive. The intuitive approach is the heap approach if you have seen this solution before. So practice this question coding through both the approaches. Also try coding the brute force approach. It might lead to time limit exceeded solution, but try coding that as well. And then if you have any doubts, ask them in the comments here. Pause this video and try first approach, then second approach. Ask your doubts in the comments. Let me know what you think of this solution. And if it was helpful, subscribe to my channel to get your updates for your daily LeetCode challenge. Thank you.